As we move on to section 2 in chapter 10, we're just continuing with section 1 but changing the shapes we're looking at. So we're actually going to look at areas of trapezoids, rhombuses, and kites. I have a feeling you've seen area of a trapezoid before, but area of a rhombus and kite might be new for you. So again, we always need to start by defining that word height because it shows up so much in our area formulas. And the height of a trapezoid is the perpendicular distance between the bases. So if you remember back from when we first defined a trapezoid, when we looked at polygons, we said the bases of a trapezoid are the two sides that are parallel. Those will never change. So unlike with a parallelogram and a triangle where we can decide which side we want to call our base, the bases in a trapezoid are always the two parallel sides. So this picture here is how we typically see a trapezoid, but we'll look at one in our first example where it's kind of a rotated trapezoid. But the bases here, the top and the bottom, we label them B sub 1 and B sub 2 or B1, B2, and the height is just that perpendicular distance between them. So our area formula for a trapezoid is area equals 1/2 times the height times quantity B1 plus B2, meaning there's those parentheses around them. So let's go ahead and try this problem. Here, like I said, here's a trapezoid. It's the state of Nevada. It's a little bit of an approximation here, but notice here that my parallel sides are the left side and the right side. That means that the left and the right are my bases instead of the top and the bottom. So just a little bit different than how we normally see it, but still a trapezoid. It still follows the same. And it doesn't matter which side we label base 1 and which we label base 2. Either way works. And then our height then is going to be the distance between them. So the height is going to be this 309 miles. So my area formula once again was 1/2 times height times base 1 plus base 2. And when we plug in what we have for each of those, area equals 1/2 a height of 309. Just got to close that parenthesis. Base 1 of 205 plus base 2 of 511. Now, if you do not have parentheses there around that addition and you try to throw this in your calculator, it's not going to give you the right answer. So you either need to do this step by step, take 205 plus 511, multiply 1/2 times 309, then multiply what you have, or make sure you're using those parentheses correctly. I'm going to show you how in the computer calculator we can do that. So just like it says, I'm going to start with 1/2, which is just 0.5, times 309, times, now open parenthesis, and you can do that on your keyboard or click the parenthesis button down here in the corner. And now you've got your 205 plus 511, close parenthesis, and then click enter. And that tells us that Nevada has an area of about 110,622 miles. And just like with section 1, we are talking about area, which means we are talking about units squared, so miles squared. One more example looking at a trapezoid, and sometimes we aren't given our height, but we can find our height using some of the previous processes we've learned. So here you notice we've got trapezoid PQRS. In this case, my bases are the top and the bottom. Those are my two parallel sides. So I know base 1 and base 2, they're 5 and 7. What I don't know is the height. And I'm just going to draw in this segment here, and I'm going to call that my height. And the reason I'm picking it on the left instead of on the right is because notice here, since that height is perpendicular, I've just created a right triangle. And if this angle is 60 degrees, that means that angle is 30. And I'm actually just going to take that same triangle, and I'm just going to sketch it over here a little bit bigger so we can see what we've got. So here's my right triangle, here's my 60-degree angle, making this 30 degree using triangle sum. And I know that this here is my height, and hopefully the fact that you're seeing a 30, 60, 90 triangle, you have kind of some bells ringing from a couple chapters ago where we looked at special right triangles and how we can find the lengths of the legs and the hypotenuse when we're working with the 30, 60, 90 triangle. So before we can find anything though, I need to know at least one of the side lengths. Well, notice here, this whole length is 7, and this much of it is 5, making this part, or this leg, 2, since 7 minus 5 is 2. Now, let's think about what we know about special right triangle, or about 30, 60, 90 special right triangle, and that tells us that the long leg of my triangle is equal to the square root of 3 times the short leg. So let's label what I have here. The height here, or the side across from the 60, is going to be my long leg, and my short leg then is the other leg, not the hypotenuse, and that has a length of 2. So let's go ahead and use substitution. My long leg is the height, is equal to the square root of 3 times my short leg, which is 2. So if I just want to rearrange that so that I don't have that number after the radical, I could say, hey, the height of this trapezoid is 2 times the square root of 3. And I could throw that in my calculator and get an approximation, but there's no need to. Let's wait till the very end to round. So now I know both my bases and my heights. I can go back to that area formula for a trapezoid. Area equals 1/2 times the height, which is 2 square root of 3, times the addition of the bases, or the sum of the bases, 5 plus 7. Now I'm going to give two answers here. I'm going to give an exact answer, meaning I'm not going to go ahead and multiply out that square root of 3, and then I am going to give an approximated answer as well. Just pay attention in your homework to see how it wants you to leave your answer. So in this case, I can't just throw this all in my calculator, since I want to give an exact answer. So I'm going to start by adding what's inside the parentheses. So I'm leaving everything else alone. 5 plus 7 is 12. And there's a lot of right ways now that you can go about finishing this, whether you multiply the 1/2 and the 2 and then the 12, or the 2 times the 12 and then the 1/2. But really what I see here is that I've got a 1/2 times 2. 1/2 times 2 is just 1. So we can kind of think of that as 3, that 1/2 and 2 canceling out. So I'm left with square root of 3 times 12, which is really 12 square root of 3. And my units are meters squared. That's the exact answer. So I multiplied through my integer and my half, and left that square root in there. If I did want to know an approximate answer, though, I would put 12 times the square root of 3 in my calculator, and I'd get about 20.8. And I'm still talking about meters squared. So again, just pay attention to how your homework wants you to leave that answer. So that's using 30, 60, 90. You do have one in your homework where you're going to be using a 45, 45, 90 triangle, so you may have to go back and review those special rules for a 45, 45, 90 triangle. Now the other two shapes we're going to talk about in this lesson are rhombuses and kites, and they actually have the same formula. To find the area of a rhombus or a kite, it is the product of the length of its diagonals times half. So 1/2 times diagonal 1 times diagonal 2. The trickiest part here is always making sure that you have that full length of the diagonal. Because the way we typically draw them in, we list them kind of in pieces. So just make sure that you're paying attention to what the actual length there is. So we want to find the area here of this kite, and we just said our area formula is 1/2 diagonal 1 times diagonal 2. Doesn't matter which you call diagonal 1, which you call diagonal 2. And look at that horizontal diagonal there. I'm going to call it diagonal 1. Notice from K to the intersection of the diagonals is 2, and the intersection of the diagonals to M is 5. So the length of diagonal 1 is going to be that length 2 plus 5, or 7 meters. Now if I look at diagonal 2, I'm going to call that the vertical one, and again, you could switch these if you wanted to. Again, make sure you have that full length. So the top portion of that diagonal is 3 meters, and the bottom portion is also 3 meters. And in this case, in the case of a kite, you should always have one diagonal where you have the same length on top and bottom, or left and right, depending on the orientation. And 3 plus 3 gives me a diagonal of 6 meters. So now using that formula, area equals 1/2. Diagonal 1 is 7, times diagonal 2 is 6. 1/2 times 7 times 6 is 21 kilometers squared. So pretty straightforward there, a lot of just plug and chug. Just the key is making sure you're picking the right values. All right, and our last one here asks us to find the area of a rhombus. Now notice we don't have a whole lot of given information here, so there's a couple things you're going to have to kind of review. One thing we know is that in a rhombus, the diagonals bisect each other, so that this length is equal to this length, and this length congruent to this length. So since the left half of this horizontal diagonal is 7, that means this right half is also 7. So I know one diagonal, and we can call that diagonal 1 if you want, is 7 plus 7, or 14. Now I don't know anything about diagonal 2. Diagonal 2 comes in here. That's my vertical. But notice I know this outside. So what I'm going to do is, just like I did on that second example, I'm going to create a right triangle. Since we know the diagonals of a rhombus are perpendicular, I can sketch in there a right triangle. And notice it has a hypotenuse with a length of 25 and one leg with a length of 7. So I can actually use the Pythagorean theorem here to find my missing leg. And Pythagorean theorem, remember, says x squared plus 7 squared equals hypotenuse squared. Or a squared plus b squared equals c squared. A and b have to be your legs, c has to be your hypotenuse. And go ahead and simplify. X squared plus 7 squared is 49 equals 25 squared, which is 625. work to get that x by itself. So we get x squared is equal to, subtract 49 from both sides, and we get 576. And square root both sides, and we get an x value of 24. Now, since we are talking about a length here, we only care about the positive value. So we're getting there. We're getting closer to being done. What we just found is that x here is 24. So diagonal 2 then, which would be from the top to the bottom, would be 24 plus 24, or times 2. Diagonal 2 then has a length of 48 inches. So our last step, go ahead and plug in D1 and D2 for your area formula, or for your area. Area equals 1/2 diagonal 1 is 14 times diagonal 2 is 48. 1/2 times 14 times 48 is 336 square inches. So again, there'll be times where you're not given everything that you need, but lots of times you'll use right triangles, whether it be a special right triangle or the Pythagorean theorem, to find that missing side length. If you have questions over any of this, please give me an email.